Hello everyone and welcome to the lecture on AWS AppSync. So this lecture will contain all these topics. What is AWS AppSync? AWS AppSync features, related service, GraphQL versus REST, components of a GraphQL API, GraphQL schema, one example of GraphQL schema, data sources and resolvers. So what is AWS AppSync? AWS AppSync is a fully managed service that simplifies building, deploying and managing GraphQL APIs, allowing developers to focus on building their applications. AppSync enables real-time data synchronization between your applications and various data sources, ensuring that your users always have access to the most up-to-date information. With AppSync, you can build applications that work seamlessly offline and automatically synchronize data when connectivity is restored, providing a smooth user experience. AppSync provides secure, scalable and serverless GraphQL APIs, eliminating the need for managing servers and infrastructure while ensuring data security. AppSync ensures high performance for publish-subscribe messaging patterns, enabling efficient real-time communication between your applications and services. You can access data from multiple sources through single GraphQL API endpoint, simplifying your application architecture and reducing complexity. You can combine multiple source GraphQL APIs into a single merged GraphQL API, thus making it easier to manage and consume data from various sources. You can publish real-time data updates to your applications, enabling instant data synchronization and keeping your users informed about the latest changes. AppSync leverages built-in security features, monitoring, logging, and tracing capabilities, along with optional caching for low latency, ensuring a secure and high-performing application. With AWS AppSync, you only pay for the API request made and real-time messages delivered, providing a cost-effective solution for your application needs. So AWS AppSync features. So simplified data access and querying powered by GraphQL, serverless WebSockets for GraphQL subscription and PubSub channels, server-side caching to make data available in high-speed in-memory caches for low latency, JavaScript and TypeScript support to write business logic, enterprise security with private APIs to restrict API access and integration with AWS Web Application Firewall WAF. Built-in authorization controls with support for API keys, IAM, Identity and Access Management, Amazon Cognito, OpenID Connect providers, and Lambda authorization for custom logic. Merged APIs to support federated use cases. So related service. So this is in relation to AWS Amplify. And if you are building a web or mobile app from the ground up or from the scratch, you should consider using AWS Amplify, because Amplify leverages AWS AppSync and other AWS services to help you build more robust, powerful web and mobile apps with less work. So basically, AppSync is one of the part of Amplify. But if you are building something from scratch for the web or mobile, you should consider this, because this has more integration. But if it's already up and running, or you are considering building a GraphQL API or app, you should consider AppSync. Okay, now I will be covering GraphQL versus REST. So some of the REST drawbacks. REST stands for representational state transfer. So REST APIs, we have observed where every HTTP resource is considered as a resource, and we have get, post, put kind of verbs like delete, and we interact with HTTP endpoints just like we interact with any kind of resource. But there are few drawbacks. So first one is multiple data request. So REST APIs often require multiple endpoints to fetch related data, leading to increased network requests. So example, you have user, you have their transactions, you have their something like passwords or groups or roles. So we have to make multiple requests to get some kind of data, and we have to hit multiple endpoints. Then you have overfetching and underfetching. REST endpoints return fixed data sets, often resulting in too much or too little data being fetched. Then you have fixed API responses. You cannot request only the specified data you need, resulting in receiving additional unwanted information. Then inefficient queries. Underfetching leads to inefficient queries, causing multiple requests and potentially resulting in the n+1 problem. Slow development iterations. As application grows, REST APIs need frequent changes to match the evolving data structure, slowing down development. And performance issues at scale. So multiple requests and inefficient data fetching can strain the network and impact application performance. Now let's see why GraphQL has some advantages over REST. So there is a single endpoint querying. GraphQL uses one endpoint for all data queries, reducing network requests. Second is precise data fetching. GraphQL allows clients to request only the data they need, solving overfetching and underfetching issues. Language agnostic abstraction. GraphQL standardizes data structure, making it easier for front-end and back-end developers to work together. Third, rapid development iterations. GraphQL's flexible data specification allows for quicker updates and less development work when changes are needed. So both are required, REST also as well as GraphQL to fetch the data. But REST, the endpoints are fixed and data schema and all is fixed. So you have to do multiple iteration in case you want to address the evolving business requirements. But GraphQL, the endpoint is fixed and that exposes the schema. So you just go get what you want. So just something like a database and you have a tables and you run SQL queries, right? So SQL and GraphQL, right? So GraphQL is over HTTP. So basically you run schema or you run query language GraphQL. So and you get whatever exactly whatever you need over HTTP. So now the key, just to summarize the key differences, endpoints. So REST requires multiple endpoints for different data requests, while GraphQL uses a single endpoint for all queries. Second, about data retrieval. REST APIs return fixed datasets, causing inefficiencies, while GraphQL allows querying for exactly what is needed. Third one is development speed. REST requires frequent API changes as the application evolves, which slows down the development, while GraphQL enables quick adjustment to data specification without major backend changes. Okay, next is components of a GraphQL API. So a standard GraphQL API is composed of a single schema that handles the shape of the data that will be queried. Your schema is linked to one or more of your data sources like a database or Lambda function. In between the two sits one or more resolvers that handle the business logic for your request. So basically you have a GraphQL endpoint, a schema, resolvers and the data sources. Okay, first we'll see about the GraphQL schema. So the GraphQL schema is essential for a GraphQL API. It forms the basis upon which the API operates and defines its capabilities. The schema outlines the structure and shape of the data that can be queried or mutated through the API. So queried or mutated in the sense it can be modified, like you can create, update. Queried means just you fetch. So it acts as an agreement between the client and the server, specifying how data will be retrieved, modified and structured in both requests and responses. GraphQL schemas are created using SDL, a specific language designed for defining the structure of GraphQL APIs. Schema definition language. So it is composed of types and fields. So SDL, schema definition language, SDL consists of two main components, types and fields, which work together to create the established structure of the schema. So first we'll see types. So types, types define data shape and behavior. So types in GraphQL determine how data is structured and behaves within the API. They will be elaborated a bit in the upcoming slides, and they include objects and scalars. So common rules for types include objects such as complex structures and scalars, which is primitive value types. Next is fields, and fields hold requested values. So field exists within the types and contain the values requested from the GraphQL service. They are similar to variables in other programming languages. And the fields allow you to predict data structure. The shape of data defined in fields allows developers to anticipate the structure of request/response operation without knowing backend implementation details. So this is an example of a schema. So you have like a person, like an object. So this is you have defined like some kind of object. and what kind of queries are allowed and what kind of mutation is allowed. So this is a very simple basic example, like it's like a hello world, but in production and all real world it will be very huge, because it will just imagine how many tables you have and how much queries you can allow and how much updates you allow. So it will be exposed through the schema. So let's see what are data sources. So in real projects, the schema acts as a single endpoint that handles all client requests, accessing, processing, and relaying data from various sources back to the client. These technologies work together to implement backend for front-end solutions, effectively reducing complexity at scale by abstracting the backend. By defining the data shape of each source, which is kind of subgraph, in a single schema, supergraph, you can abstract every complexity from multiple data sources or microservices. GraphQL API is not limited to one data source. You can link many data sources to your API and define their interactions in your code. So this is kind of all the data sources are subgraphs and the whole schema is like a supergraph, but you are hiding away all the complexity from the end users or the clients, and you are wrapping it in a GraphQL schema, so they will not be even aware that how many data sources it's talking to. AWS AppSync supports various data source types, and this thus making it versatile for different use cases and project requirements. So some of the supported data sources include DynamoDB for NoSQL database, Lambda for serverless computing, OpenSearch for search and analytics, HTTP endpoints for external APIs, then EventBridge for event-driven architecture, and relational databases for structured data storage. So it covers pretty much any kind of use case. So you have an end client, or for example mobile app, and it is going through AppSync. So depending on whatever be the kind of situation, it can handle, because it supports pretty much. So if you have search based, you can backend can be OpenSearch. If you are doing some kind of a trigger or serverless computing, you can invoke a Lambda function, or DynamoDB for NoSQL, or SQL relational database for SQL needs. So let's see what is our resolvers. A resolver is a unit of code that manages how a field's data is resolved when a service request is made. So it acts as a bridge between the client request and the data source. So just imagine like you are asking something and resolver is the code. So this is the code part. So you have a schema and the resolver. So resolver will resolve from where to fetch, whether it's a query, whether it's an update, whether it's a subscription. Resolvers are connected to specific fields within the types defined in your schema, and this attachment allows for precise control over how each field's data is retrieved or modified. So for example, in the person example, we have the ID field. So ID will be attached to a resolver. So that resolver will know how to handle the ID. Or just think of a column or a field in a table. So in a column or a field in a table, you just attach a resolver, and resolver has the logic about how to fetch, query, or how to mutate or update the data. Resolvers are primarily used to implement state changing operations for query, mutation, and subscription field operations. They handle the logic for retrieving, modifying, or subscribing to data. Okay, let's see how is the request processing. So when a client makes a request, the resolver processes it, applying the necessary logic to fetch or modify data. The resolver then returns the result, which can be a group of output types such as objects or scalars. Scalars are just think like a single unit. Objects are multiple scalars, like a structure, like a JSON object kind of thing. Okay, so which can be a group of output types such as objects or scalars, depending on the operation and data structure. In AWS AppSync, you must specify a runtime for your resolver. The runtime indicates the environment in which a resolver is executed and determines how the resolver will function. So it needs a runtime because it's some kind of a code which is running. So code which is running. So let's say it needs when you run some code, you need Java, Python, or some kind of runtime. So resolver also need to run in some kind of a runtime. So AWS AppSync currently supports two languages for writing resolvers. First one is JavaScript based, which is through AppSync_JS runtime. This is one option, and second is Velocity template language. which is a templating language designed for embedding logic into text. So currently it supports 2 resolvers. And that's all. Thanks for watching.